Welcome to Brain Vision.
So we know that the applied force causes a torque, which gives the pulley an angular acceleration. We know that the applied force varies with time, and if this is the case, so will the angular acceleration. We can say that in order to find the angular velocity, we can integrate the variable acceleration to solve for this, and then we can then say the speed of a point on the rim is the tangential velocity of the rim of the wheel. So we can set this up and say that sigma tau equaling the radius times the force tension, and this would be equaling the moment of inertia multiplied by the angular acceleration. So we find that the angular acceleration would simply be equaling the radius times the force tension, which is again varying with time. And this would be divided by the moment of inertia. From the definition of the angular acceleration is going to be equaling the derivative of the angular velocity with respect to time t. So we can then say that we can integrate from omega initial to omega final times d omega, and then this would equal the integral from 0 to t of the radius times the force tension divided by the moment of inertia dt. And so we know that the angular velocity is equaling the linear velocity divided by the radius, and this would be equaling the initial angular velocity plus r divided by I multiplied by the integral from 0 to t of the force tension dt, given that the force tension is the only variable that actually depends on time. So we can then say that the initial angular velocity is 0, so we can eliminate that, and we can then say that the angular velocity would be equaling the radius divided by the moment of inertia multiplied by the integral from 0 to t of the force tension dt. And we're simply going to then, we can simply say that the tangential velocity would be equaling the final velocity times the radius. And so this would be equaling the radius squared divided by the moment of inertia times the integral from 0 to t of f sub t. Now this would be equaling 3.00 t minus 0.20 t squared times dt. And so we can then solve and say that this is going to be the tangential velocity would be equaling r squared divided by the moment of inertia multiplied by 3/2 t squared minus 0.20 divided by 3 t cubed, and the units Newton seconds. And we can then say that the velocity, the tangential velocity at t equaling 8.0 seconds, this would be equaling the radius of 0.330 meters divided by the moment of inertia to be 0.385 kilogram meters squared. And then this would, the radius would be squared and then multiplied by 3/2 times 8.0 seconds quantity squared minus 0.20 divided by 3 times 8.0 seconds quantity cubed. And then again here, the units here would be Newton seconds. And we find that the tangential velocity at t equaling 8.0 seconds would be approximately equal to 17.5 meters per second. This would be our final answer. That is the end of the solution. Thank you for watching.